Hi, it's repair time again. We've got some studio monitors yet again, near-field studio monitors. Very nice bit of kit these. These are Presonus Eris E5s. The 5 in that name, of course, means a 5-inch woofer on here. We've got a tweeter, two-way jobby, not sure what the crossover frequency is, and a nice front port. I much prefer the front ports on these near-field monitors. And these are a really nice bit of kit. They're almost unused. Absolutely fantastic. But one, reportedly, it goes pop when you turn it on or something, and it doesn't work. So anyway, we'll have a squiz at it. It's got all your low cutoffs and your acoustic space, which is your attenuation, and your various inputs as well. Designed and engineered by Uncle Sam, but made in China. Well, this one here works. You can hear that annoying voice coming out, but
in this
can you hear it?
coil,
like there's
pops,
somewhere.
It
there's like crackling and stuff.
Transistor off instantly, but
I thought it was
field has to go somewhere, and that energy has to go somewhere in the form.
And I thought that was actually put in my shoe phone on top because I'm transmitting via the Bluetooth.
Just gets higher and higher and higher. Something has to give. The stored energy in that magnetic field has to go somewhere. If I take the phone away completely, just like if you short out a battery, there's energy build up in that battery. You'll get sparks, and there's a lot of energy.
There's no pop in,
and you
can
bring
the phone in,
and the same thing happens with the coil.
Wow,
there's X amount of energy build up.
Is that a shielding issue?
And
in the
Faraday's law of electromagnetic induction is about, and in particular, Lenz's law.
Ironically, talking about electromagnetic induction there. Wow.
The inductor in this particular case,
try this again.
Relay coil will
try this again.
Will actually be opposite to what actually produced it.
No.
So when we've got the transistor switched on, of course, the voltage will be positive and negative like this.
Will try this again.
Will actually be opposite to what actually produced it. So when we've got the transistor switched on, of course, the voltage will be positive and negative like this.
All right. So that popping, nothing to do with interference in the phone. I thought it was.
Measuring from, so everything
but I can't reproduce that now. What's going on?
It's spinning.
So this good one here, I can't get any interference whatsoever. There's no pop in, there's no nothing. And unfortunately, I couldn't, didn't have the camera roll in, but this thing was, the faulty one here was actually pop in, even when I didn't have the phone anywhere near it. It was just, giving like pop, just like occasionally like that. And this is a classic fault with electrolytic capacitors. What can happen is that you can get dielectric breakdown, like due to, like high voltage or like not over voltage, but just, during normal operation, you can actually get a voltage breakdown between the individual layers on, because an electrolytic capacitor, I'll try and put up a photo, is a big roll of, you can take one apart yourself and you can unroll it. It's a big roll of dielectric, and you can actually get little micro breakdown between two of the layers, and you can get like a little arcing between those layers, and that arcing generates a little current in the capacitor, and that's what causes it, and that somehow gets into the amplifier chain and causes a pop, depending on where the capacitor is in the circuit. So it's a classic fault. So yeah, I think it's just one of the capacitors has just come a gutser inside here, and it's doing some like dielectric breakdown, arcing, and hence popping. But unfortunately, it's probably going to be hard to find out which one. Now this claims to have a Class AB amp in it with 80 watts total power. We've got self-tappers into particle board, of course. That's what you'd expect. Pretty common. But it looks like we'll get all these around here. Looks like these are the heatsink jobbies, so won't take those off. Yeah, there we go, lifted it out. And we're in like Flynn. There you go. Got our acoustic filler material. That looks pretty groovy. Pretty standard fare for a near-field monitor speaker. We've got down here, once again, nice attention to detail around the IEC and the connectors and the mains voltage selection here. They're all sealed because you don't want any air to leak out, because you want everything to go out the, purposely designed acoustic port on the front, of course. And, well, that transformer, that's looking a bit how you doing. That's not vertical. So I think this has had a drop in that direction, like a vertical drop, and she's bent a bit, but it's neither here nor there. There's the specs on the transformer for those playing along at home. We've got two board construction here. We've got our power amplifiers, of course. They're a staggered pin package like that, just connected directly to the heatsink. One would be for the tweeter, one would be for the wooferys, and the rest of it is just basically the mains power supply. You've got your big bridge rectifier just flapping around in the breeze there, but that's all right. They've insulated one leg. I'm not sure why, they've just done one, but anyway, interesting. And because speakers tend to vibrate, it's kind of like their job. They have actually sealed up they've gunked the connectors here to stop those going wiggle, 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 yeah, and coming apart. But interestingly, they've got a filter board down on the bottom like that. And once again, they've got some good gollops of hot snot. Somebody had fun there. Gollops of hot snot around the connector to make sure that doesn't do anything. Anyway, odds are that we're not going to have an issue on the filter board down here because, well, you know, there's not much that can really go wrong on there. You've just got your surface mount ceramic caps and your semis and your resistors and passives, and that's, you know, that's all she wrote. So it's more than likely something up here on the power supply. Those mains filter caps, the vents in those look fine. There's no bulges. What's the brand on that? Who or what is cap top? I don't know. I don't think I've encountered cap top before, but doesn't exactly instill a lot of confidence. Come on. These aren't super high price, high end monitors, but they're supposed to be. Like, Presonus is, you know, a pretty decent, reputable brand. So, come on, do better. Another attention to detail is the foam over the wires here coming from the transformer. That's not for insulation, that's for acoustic reasons, just so that the wires don't vibrate against the metal like that when your woofer's going woof woof. All right, I turned it back on and can't hear any pop pop. So, looks like we've got an intermittent fault. So that's annoying, especially if you want to like try and do some measurements and stuff to try and like, you know, see what's happening. And well, if it's an intermittent, I don't know, you just got to have a guess. And do these have any inherent hiss in them when you've got no input? I'll turn the volume, the input gain all the way down and tongue at the right angle. Yeah, I can hear it. It's not the worst I've heard, but yeah, you can hear the hiss coming out of the tweeter, so there's just an inherent noise floor there. I've done a video on this. It's reasonably common in like studio monitor speakers. This one doesn't look like have like an auto mute thing that literally cuts off the output. It's just like the inherent noise gain of the amp. The annoying thing is though, I can't get it to reproduce the pop pop coming with the phone nearby either. So it's some weirdly intermittent thing, which is just, yeah, really annoying. In this particular case, what do you do? Just recap the whole thing, probably? Ugh. I mean, they got those, what, top caps in there? Ugh. Let's just measure the rectified DC here, straight across the bridge rectifier, the two outer pins there. You can see it, we've got 48 volts DC, measuring on the new BM787 Bluetooth. It's the new Bluetooth model, so you can pair it with your shoe phone over here, but we won't do that today. So 48.7, yeah, that sounds good enough for Australia, but what's the AC on that? The AC component of that is only 0.129 volts, i.e. how much ripple it's got, basically. Let's turn it up. The ripple is increasing, but nothing shocking, really. So, you know, it's not terrible, Muriels. The integrated, like the IC amplifier on this thing, I haven't even looked at the part number on that, but yeah, that might be partial to, like, you know, supply variations, you know, ripple on your supply. So, yeah, anyway, it's not that bad. That's why it's working. So there's two huge primary filter caps on there. You're not going to get any value from Whoa, did that just jump? Was that my imagination? I have to rewatch the video. You're not going to get any value from Whoa, give that a little poke. Nah. Thought I swore I saw something. Assuming that's what the fault is. It's usually capacitors. So rather than leave the camera running, I'm just going to record this and get our min-max, and I'll just leave it for a bit and come back. And that'll tell me if there's been, like, you know, some like weird max excursion. So I just had it there for a couple of minutes, and sure enough, it jumps up to 0.195. So yeah, like there's something doing there. Interesting, huh? Just trying to get the board out here, and there you go. It's taking the screws out, but some of that sealing gunk has got its way along there. So I'm going to have to get a knife and slice and dice. Thankfully, I have a rather large knife. There we go. Got it. Yikes. Jeez, that was tough. Wasn't much stuck on at all. All right, let's just have a look over the board here. We've got it out. As I said, these are cap top brand, and all of them, all the capacitors on here are cap top brand. So they're the output of some linear regs here, the 7812 and 7912 there. So plus minus 12 volt rails. You know, there wouldn't be any problem there, so you wouldn't even bother replacing those. And yeah, they're all cap top. Leave in the comments down below if you've heard of cap top. And the amp down there, this is the tweeter, I believe, TDA 7294, or is it 44? It's a 94. Oh, got some fiber in there. And of course our PCB is single-sided, but it's got the silk screen, it's got that blue silk screen on the top to show you, like, you know, the layout on the bottom. I really like that. That's a nice touch. And the other one for the woofer is exactly the same, TDA 7294. I'll put up the spec sheet here for that. So without looking at the schematic for that, it looks like, you know, these caps here, probably some local bypassing. Got ourselves a couple of old school green caps, and they've glued that down to the electrolytic capacitor next to it, just so that, once again, these don't flap around and vibrate with the, you know, because that would be a really rather annoying. Anyway, the woofer outputs here are directly soldered into the board there, and the negative for the woofer and the tweeter are going right down to there, which is the star ground. Basically, that point there, that's the star ground for those capacitors there. So that is good layout practice. Just going to have a cursory glance over the solder joints just to make sure they're okay. Look at that. There's some dag in there, is there not? A bit of solder splash there. But what I don't like the look of that resistor. Oh, no, I think it's just the light. Oh, no, that's okay. That really looked bad from the side, didn't it? No, it's okay. So those solder joints all look fine. You know, you wouldn't expect an issue there to cause a pop. You're more likely to get some dodgy electrolytics, and there's not much else doing on the bottom. Filter board solder joints look fine. Interestingly, though, there's a whole chippy here missing. These little orangey red dots, these are the glue under the components, so that they hold the glue down when they go through the wave soldering machine. So all these surface mount resistors, they're all, and surface mount chips on the bottom, they're all, well, there's supposed to be one there, but it ain't there. I don't know what that is. Is there an option on this speaker? Is it some sort of, because it doesn't seem to have a power on mute function. Is that like an optional power on mute thing or something? Anyway, I'm not going to reverse engineer the pinout on that, but there's something doing there that they clearly didn't need. So, okay. Sure enough, this board is only for the Eris 5, so it's not used on any of the bigger ones. Yes, I accidentally pulled out the connector there. I thought I had the glue off this connector, and I didn't, and it pulled straight out. Oops. So yeah, I don't know. I don't really want to go probing around on this thing because the stupid folder's intermittent anyway. So, you know, you could be there just scratching your ass until nothing happens because, you know, white coat syndrome. Murphy will be watching and the fault won't happen when I'm probing it. So the best thing to do, I think, is just to give it a recap. Yeah, we'll see what happens. Unfortunately, the glue holding down a lot of the caps in here is really annoying. That doesn't make them trivial to... Anyway, I'll desolder them, see if I can just pull them straight out. Maybe we can do some measuring. Okay, I'm just looking at the woofer amplifier here. Pin 10, which is this one of the amplifier, that's the mute pin. So I'm just following the money there. It does actually go off. Whoop, get rid of him. It does actually go off somewhere to some network over here. So it's got some muting, you know, power on muting capabilities. So that rules out over here. That was always, you know, too complex for that. There's probably a capacitor on top of that. There you go. So that might be power on muting circuitry. Getting this glue off is going to be a real pain, especially around these areas. Really hard to access, and it's really hard to soften this stuff up too with heat, so it's not pretty. Well, I got him. It ripped the black plastic off the bottom, but crude but effective. It was probably the best way of getting that out, really. Let's measure the ESR of this bad boy, shall we? At 100 kilohertz. It's good, yeah. So that's why, like, we were seeing good ripple on the thing, but yeah, like it was jumping up a bit, but yeah, like, it's fine. 4400 mic, there you go. So yeah, I mean, the big caps are fine and dandy. So there's something else. I mean, you know, I could get that one out as well. Might as well. So what else have we got on here? Well, that resistor there, what is that, 4.7 ohms? And that green cap there, that'd be a Zobel network on the output. That's basically in parallel with the output, in parallel with the speaker. And you'll get one over there too. There it is, down there. Nothing doing there. Might have to follow the money on a few of these caps. But yeah, like some of these caps around here. But, you know, it's hard to know what's causing it to go pop. And we can get a good look at that preamp board there as well. So, if they, what do they got? Yeah, there's a number, 4558. What a surprise. Can't even read the first number, but I know what it is. Because that is the classic audio op-amp. Jeez, look at the solder splashes all around there. It's a bit how you're doing, isn't it? So, they didn't give that a clean ski when it came out of the solder bath. I don't see anything doing on here. I mean, you know, it's a possibility. Theory, you could have an issue with one of the ceramic caps in here. There'd be nothing else doing, really, that would cause anything like that. So yeah, you really wouldn't suspect this board. Not impossible, but yeah, culprit's more likely to be pesky electrolytics. So my next thought is, what is the most likely culprit? Well, what is the one that's nearest the heatsink, right? The heatsink's the thing that gets hot, and the enemy of electrolytic capacitors is heat. So that one there is, it's not touching, but it's pretty darn close, right? So that is going to get, and that one as well, because these are basically two identical amplifiers, one for the woofer, one for the tweeter. I think it's worth sucking out those. Yeah, this is the tweeter one, this is the woofer one over here. The low frequency popping is likely to be on the woofer side of things. That's what it sounded like. So I decided to follow that, and if you flip it over, so that's the capacitor there, and it goes over to pin 6. It's not pin 3, because here's 1, 2, 3, 4, 5, 6. Pin 6 is the bootstrap pin. And that is connected directly from the bootstrap pin to the output here. And that, if you've got a low bootstrap capacitor in this amp, then yeah, that could possibly cause it. So I'm going to suck out these two caps and test those. Let's measure the ESR of one of them here. 0.28 at 100 kilohertz there. That's pretty low. 0.28 ohms. These are 50 volt, 47 mic caps, you know. Typical figure for a non-like low ESR one, because these aren't low ESR jobbies, you know, half an ohm. So like if you started seeing like half an ohm, like if you started seeing ohms, you'd be worried. But no, that's fine. Let's measure the other one. The good thing about this is that even if we don't know what it's supposed to be, because we've got two of them, two identical circuits, we can measure them. What? 4, 3, 6, that's high. Oh, no. 2, 7. Same. And that'll be fine if we actually measure the capacitance there. That'll be 47 mic. No, that's at 100 kilohertz. And yep, that's fine. So not those, but you'd still probably replace them as a matter of course, given that you've already taken them out. Okay, I measured a cap here in circuit. You can usually do that with ESR at 100 kilohertz. Usually, not too much of a problem, so you don't have to suck them all out. Measured that one, and it was measuring like 1.5 ohms, so it's a little bit high. I'm going to suck him out. So 1.38, it's not bad, but let's, do we have a comparison? It's a 10 mic 50 volt. Okay, I got another one out of the board, and we're 1.7 ohms. And I was just thinking that these things, these are all 50 volt rated caps, and you know how we're measuring 48 volts DC? That's not much of a margin. I'd be putting in, you know, like higher voltage caps than that. 50's a bit, it's a bit closey. Another one I pulled out, 1.4. There you go. Auto turned off. Yeah, that's my best guess of what's going on here. So really the only thing to do is just simply replace all the caps. Except for those two I told you about on the outputs of the voltage regulators here. They'll be fine. There's no need to touch those at all. All right, I'm pretty much out of stock of like good quality replacement caps. So I went to JCar, and JCar to the rescue. They still have the old school cardboard drawers with all the capacitors in it, and I got my suitable ones. I couldn't get a 63 volt jobby on the 4700 mic, and these are just like suntan brand, right? So, you know, if you're going to do this properly, then you want some, you know, some Panasonic, some Nichicons, anything made in Japan. All the best stuff's made in Japan. You want Japanese capacitors. So anyway, I could only get those in 50 volts, so it's on the margin, but 50 volts it is. But the others I could actually get in 63 volt jobbies, all of them. So 22 mic, 10 mic, and 47 mic. And the 47 mic ones are the low ESR version. So we'll just have a quick measure of that. There we are, yes, 0.31 ohms, nice. So therefore the mute pin on pin 6 was it. So yes, I will use some low ESR jobbies there just in case. The others are just like just regular Joe Blogs ones, whatever. 63 for most of those, but anyway, let's go replace them. All right, I've gotten all the caps out of there except for the 12 volt reg ones over there, as I said. Because I want to target all the ones on the 50 volt rail. So I'm just going to leave all that crap there. I'm not going to try and dig that off. So yeah, I'll get back to you when I've installed all the caps, hopefully with the correct polarity. Okay, I do have a map of where all these go. So that's positive there. So I want to flip that around. Little pro tip, if you're PCB designing, don't put the positive under the capacitor, like put it outside the circle there. There's plenty of room there, because once you put that in, it's covered up. You can't see it anymore. It's not good. Can't double check. Last of the small ones. Positive over there. Oh, bit of a pad missing there. Bummer. Happens. And beautiful. Looks like we've had some collateral suck damage there on that pad. We'll put that back. Okay, and unfortunately, we have a pad removed here, so, you know, it happens. So, yeah, I'm just going to have to bend that lead over. It obviously goes over to that resistor there. So, yeah, I'm going to have to bend it over. That just came, yeah, that just came straight off. Didn't like that at all. Oh, I must have just had a dag. Didn't get all the solder out when I pulled it through, and then whoopsie. Soldering in the last of the Big Daddy here, and there you go. Bob's your uncle. We are fully capacitor replaced. But because I'm super duper paranoid, here's the positive pin of the diode bridge and the positive pin of the cap, and it is shorted. And the negative should be the other side of that capacitor over there like that, because it's center tap
in the middle. I was wrong about the ratings on these big caps here. I thought they were in parallel. I thought we just had the one rail. No, it's split. Here's the positive output of the bridge rectifier, right? It goes over to the cap over here, and then the negative one over here, actually the negative output, instead of going to here, of course, it goes all the way over to here. Boop, there's a jumper, which then goes over to here. So these are actually in series across the 48 volts, so they're only seeing half voltage each. So we have our split rail there, and that's our ground point for our, so it's basically a plus minus 24 volt rail. So the 50 volt rated caps there is fine. All right, let's power it back on, and I hope I've got everything around the right way and the magic smoke doesn't escape. Let's go, shall we? And she's on. Play. No, what's going on? Let's measure that voltage again, and, ooh, 50.9. We're up where we were before. That's good. Or has my mains voltage changed? Okay, I've confirmed that there is audio coming out of here. I hooked it up to the other speaker up the top here, and there's nothing coming out of this one. So what have I forgotten? What have I goofed? Well, there's your problem. I forgot to put 2 caps back in. It pays to count the number of caps you took out and then count the number of caps you put back in. I was too short. So whatever that's doing there, yeah, that's Kamagatsa. So dumb. Okay, one more time for the dummies. Let's see if that makes a difference. Let's turn up the volume. Oh, it helps if I play. No, we're still muting. Am I still connected? No, I'm not. That's the preamplifier board. Oh, just not cutting a break today, am I? Let's power it on again. Hey, there we go. Winner, winner, chicken dinner. So, now, I'm just going to have to put it through its paces. I'll spare you the details, but there's no pop in.
So obviously the emitter current's going to
no pop in. I don't think that's a thing.
Well, it's the same, right? The current, it just flows down in the circuit. The current through
that sounds good.
As the current through the
that sounds good.
So you'd expect the waveforms to be the same.
I do believe we have a winner chicken dinner. I will do more extensive testing, of course, but yeah, I think we've just, like, which cap failed? I don't know. You'd have to test all of them under voltage. Not all of them are being run at, in fact, probably most of them aren't being run at that 50 volt voltage, I don't think. Don't have an actual schematic, but I don't know, if you go by the application note or something, you'll find that probably most of them are a split rail things, so they're operating at 24 volts. But anyway, our mains voltage did go up, but it is the next day. So I measured it at 48 volts yesterday, and now it's like over 50 volts today. So I don't know, the mains voltage might have gone up in the day. It varies, you know, a reasonable amount during the day. So there you go. So unless I want to actually individually test each one of those, stress them at voltage to see what's going there, but I suspect there was just like breakdown in one of the caps, like a voltage breakdown thing that was causing a pop. So you know, a bad cap. Which one it was, don't know, but anyway, it's good practice to like recap the entire thing. Yeah, I didn't use Japanese caps, I know, but I don't know, these are like these aren't exactly my focal speakers. I'm not going to give up my focal near-field monitors for these Presonus jobbies. They're not bad, the Presonus, but you know, you get what you pay for kind of thing. These are sort of like the low to mid-end kind of stuff, but they're still pretty decent. The studio monitor speaker. So anyway, that's a repair. If you liked it, give it a big thumbs up. As always, discuss down below. Catch you next time. Oh, and all the EEVblog merch over on eevblog.store.